Hey, this is JC from Bear Market Labs. Bear Market Labs is a new org building in the bear market. In this video, we will provide a Python approach to using IBC. Um, so, yeah, one of the first projects we put out to the public is a Python version of the IBC relayer. Currently, there are three production grade ones written in Go, Rust, and TypeScript, and we hope that we can we can uh, we can provide this Python alternative for developers. Okay. So more specifically, the PyBC relayer is a translation of Conthio's TypeScript relayer, and we also borrow their contracts for the example we will go through in this session. Okay. So what we would do is set up an ICA smart contract on injective and osmosis, right? So an ICA is interchain accounts. So this is not that ICA that is like the custom module on chains. This is the CosmWasm version that was put out also by Confio about 2 years ago, which provides ICA functionality, but using only CosmWasm smart contracts. So in this session, we want to basically get this set up. We want to have a pair of smart contracts, one on injective, one on osmosis, and we want them to be connected. And we want the injective side smart contract to basically be able to issue commands to the osmosis side smart contract. An example would be like, hey, can you please swap 100 X to Y using the osmosis balancer pool, for example. So we will use IBC basically to achieve this. Okay. So what I will do is we have put out a series of notebooks to kind of walk through the steps. Okay. Additionally, on our repo, we also have scripts that are basically just a command line version of the notebooks. If that's that's another alternative to running these things. So yeah, let's go ahead and get started. I have my Jupyter notebook server up, and we have 5 notebooks. The first one's really just an introduction to kind of set the stage, if you will, right? But the first steps towards setting up any IBC relayer is to get the client set up, right? So first, let me restart my kernel. So as I go through the notebooks, I'm also going to try to, in parallel, do the same here, so that we can kind of tie, the visuals or the flowchart to what the code is doing, right? So yeah, let's get this first thing started. So what we do first is we create what's called a light client on each chain. Okay. So originally, we have this injective chain and osmosis chain that we need where we want some interchain communication. Okay? And that first step is to create these little guys, little light clients that will be almost posted to each chain. Okay. So let's go ahead and do that actually. Okay, so one thing to note is that we do use the Terra Python packages pretty extensively. They're actually very flexible. There's no need to use the Terra blockchain to use their Python SDK. It's really just a light wrapper around just REST calls to the LCD clients, as well as they've already generated all the protobuf message classes in Python. So it's just super convenient to use it. So at least I like it and find it it's really almost like the fastest way to just get something up and running. So yeah, you can see that we actually can just create injective objects and wallets and osmosis stuff here. So yeah, the first step to creating the light client is to basically fetch the Tendermint consensus state from each other. So on the injective side, we need to fetch the osmosis tendermint state and kind of post it to the injective chain as that like client. Okay, so that's what this whole cell block is basically doing, right? First thing it does is we fetch the osmosis like tendermint state. What's the latest height? What's the last block hash, and stuff like that. And what this does is this will generate that like client on injective. So here, the ID of that like client is 07 tendermint 102 weird 100-second like client on injective. Okay. And we'll do the same thing on the osmosis side. So now we need to fetch the injective state over here and create a like client on osmosis. In this case, it's the 4,558th like client on osmosis test nets. Okay. And yeah, that's basically it. We have created 2 like clients, so this step is complete, and we will persist these to a local file just for easy fetching later. And that's it for IBC client setup. Okay. So before we move on to the connection setup state, and actually let me do that first. Okay. What I can do is I can do a quick flyover of the whole process, just so you guys know what's coming up. Okay. So what we've done is we've already created like clients on the chains, right? They each have a snapshot at some height of their counterpart. So the next step is to create the bridge itself, the IBC connection, right? The IBC connection is the general purpose message conduit that basically serves as like that core bridge infrastructure. There's no actual messages being passed through the IBC connection specifically. What you would do, and so when you do want to have specific communication between 2 things, like in our case 2 ICA smart contracts, we create ports, right? So once the connection is established, we can create ports, the endpoints, if you will, to channels, right? These are the ports, and they're connected by a channel, right? That is almost like hosted on this IBC connection. Okay? And with this channel, we can actually do what we set out to achieve, which is to have a smart contract on injective, issue commands to do stuff on osmosis and get some feedback, to get this communication pattern going interchain. Okay, so let's come back now. So this is what the success state looks like for our workshop. So now let's go ahead and go through steps to create this channel here. So just reading off the texture. The second step is this 4-step handshake between injective and osmosis. And you'll see what these 4 stages are as we go through it. And this is going to lay that, this is that foundational bridge, right, that will facilitate channels between 2 modules of the 2 chains. Okay. So again, let's import all of our libraries and wallets, as well as our client IDs. Okay. All right, so the first step is this thing called message connection open init. This is called on injective, okay? So we are basically initializing this connection, this IBC connection. Okay? And this is called on injective. And we are issued a connection ID. In this case, we are the 83rd IBC connection on injective. Okay? The second step is to now do this reciprocating connection open on osmosis. This is called the message connection open try stage. So this is actually a lot more involving than what you saw earlier, because on the inject side, we just call it like, hey, let's just call it. We are call open init, connection open init, and we will get a connection ID. Okay, we have published this, we have posted this transaction on injective chain. Okay. On the osmosis side, we want to start opening up a connection too, but we have to verify a couple things. So firstly, we need to update the client itself, right? So the osmosis chain will update the like client, the injective like client here. That's what this enormous cell block is. which is basically just fetching the injective tendermint states, consensus state, and basically we're packaging a message update client message, right? So, okay, it's finished. And it's really just packaging all the tendermint consistency information into a message. So along with an updated, update injective state, there's this injective client, we also need proofs that injective did in fact dispatch this connection message, as well as we need a proof of this updated state, as well as we need to actually fetch some consensus state of osmosis itself, right? So we basically gather a lot of proofs. So that's what this is doing. This is the proof that will corroborate the updated injective client. This is the connection proof to prove that yes, injective did call in connection open init. And this is some osmosis side consensus information, right? We take all three of those things and we package it all into a message connection open try transaction, right? So let's go ahead and call that. And what we get out of it is the osmosis connection here. So this is a 3,975th connection on osmosis and the 8th on injective. But cool, we have our connections posted in both chains now, but we have to go through one more cycle of basic acknowledgements. The third step is called message open connection open EC. This is called injective, right? And it's going to basically mirror the steps that we saw earlier, where injective is going to update the osmosis like client, right? By fetching, we're going to do the update client by fetching all that tendermint information from osmosis. Then it will fetch all the proofs, right? Kind of mirroring that previous step. We're going to fetch a proof to corroborate the updated clients. We're going to fetch a proof to corroborate the call, right? This call, the message connection open try. Did you create that message number 3975? As well as we'll pull some injective side consensus states. And once that is done, so here it is. We fetch the proofs here and update the client. Okay, I think that's done. We will go ahead and now dispatch our message connection open ACK, right? This is the third step of the connection creation process. Yeah, and that went through successfully. Okay, so as the final step, we will do a final, the final series on osmosis. Again, with the same process called message connection open confirm. And we will update the injective like client. We'll fetch the client proof to corroborate that update like client. We'll fetch proof that injective acknowledged, right, the connection, that connection open EC, as well as consensus proofs for osmosis. And all these things get packaged together for the final message connection open confirm. Cool, that's it. We have created the IBC connection between injective and osmosis. Awesome. And we will persist that to a file. Okay. So we now have our bridge. So let's go ahead and just get our two smart contracts connected. So move on to the third notebook. And again, let me just actually make sure we have a clear kernel, right? So we have our IBC connection between injective and osmosis, and it's ready to service communication between any two ports. The ports in our case are the two ICA smart contracts. But the ports can also be like native modules. So the most common channel actually is the transfer channel, which is for transferring IBC assets, right? So that the bank module on each chain can basically like talk to each other. But in our case, we're just going to be having two contracts as ports here. But so in our case, we're going to try to get these two connected. And let's get these guys all imported. So setting up smart contracts is the normal process here. So there's nothing IBC specific about this. All we are doing is just deploying just WASM, like the same Cosm WASM binaries that you do for any Cosm WASM contract. So what we do is I've already uploaded the WASMs beforehand. So on Injective, we have the ICA controller, and we have on Osmosis the ICA host as well as the CW1 contract. And what this is doing is just, it's just basically just deploying the two contracts. So the controller is that, the controller counterparts of the ICA, I guess, I don't know, relationship here. The host is the one that kind of follows the orders of the controller, almost like a subordinate or like a worker contract. And the CW1 is a very generic, it's a generic smart contract that just does what it tells, whatever you want it to do. An example would be like, you would launch, or sorry, you would instantiate a CW1 contract. You would fund it with some funds. You put like some assets in there, and at that point, you can just tell that CW1 smart contract whatever you want it to do. It's almost like a wallet, except it's a smart contract. It's basically a very lightweight smart contract wallet or smart wallet. So that's what's being deployed here. We have our controller set up here at this address, and we have our host or our subordinate smart contract at this address here. And the interesting thing, at least in their implementation of ICA, is that the host address, this guy, will actually spawn a CW1 smart wallet, really, to serve as the actual thing that executes commands on behalf of the controller, right? So the controller tells the host to do something, and the host tells his own CW1, hey, you do this, right? That's kind of that hierarchy. So anyway, we create our ports, and that's it. There was nothing IBC related here. So yeah, so this notebook actually, I've actually packaged in also the channel stuff, just because setting up the ports is actually pretty straightforward. Okay, so with our ports made, now let's go ahead and create that channel. Let's get these two guys connected through the connection and using the connection we made earlier. Okay, so the IBC channel setup is a 4-step handshake between two ports, our controller and our host. Again, with a very similar handshake methodology, where they basically go back and forth in these 4 steps. Okay, it is conceptually and procedurally analogous to connecting two IBC clients through an IBC connection. It's gonna look very familiar to what we just did. Okay, so the first step is this message channel open init, right? You've got the same suffix, right? So let's go ahead and run that. Okay, so on the Injective side, we have initiated this channel open process, and this will be the 56th channel ever made on Injective. Okay, and we will, this step is done, so we will go on with the second step to be run on Osmosis, actually, called message channel open try. Here is the same familiar, steps of updating the like client, right? So Osmosis will update its Injective like client right here. I'll just get this off actually. And then it'll fetch, and then in the next step, it's gonna fetch proofs to basically verify, hey, Injective, did you execute this open channel transaction? And that's what the channel proof is, to corroborate that. So this is the message up. This is to update the client, and here we'll fetch the proof. Basically, fetch that, ask Injective, or that did you initiate this channel open? Okay. With these 2 pieces of information, we will package that together into a message channel open try transaction that will be finally called on Osmosis here. So now the Osmosis side will publish that, all right, we have reciprocated this channel initiation opening. The channel ID on our side is channel number 7,948th. It's the 7,948th channel on Osmosis testnet. And yeah, we will again go through another iteration on Injective as the acknowledgement, sort of acknowledgement loop. So yeah, again, we will update so now we're on now the ball is on the Injective side, and we will update the Osmosis like clients, and then fetch the channel proof to corroborate that the Osmosis side did in fact call message channel open try, and that's what the channel proof is. And we package those piece information together to for this acknowledgement call, this message channel open hack. Okay. I'm going to just run this for now. I'll come back to this later, but it's actually pretty important for this ICA setup. Okay, let's just finish the channel construction, the channel setup here. So, okay. And again, this is the final piece where Injective just acknowledged the open channel, the channel open request, and we need to do a final confirm on the Osmosis side, right? It's like 4 separate transactions to officially spawn the IBC channel. Okay, so this here is just fetching this is basically just updating the Injective client, right? We're updating the client here, and then we'll fetch the channel proof. We're basically asking Injective, did you call the ACK transaction? Okay, and then again, those are packaged together to open up the channel. Cool, and we're done. So at this point, the IBC channel connecting the 2 contracts is complete. We are all connected, okay? This has happened, right? So we have 3 channels here. 2 contracts are now linked, right, on channel 56 on the Injective side and channel 7948 on the Osmosis side. But we're not quite done yet. So a specific step for the ICA contracts we used requires actually, so what's happening is that the controller contract during the channel setup, it will also ask, it actually sent a Genesis packet to basically ask, hey, what's your address? He wants to know what's the address of his subordinate on Osmosis, right? So during channel setup, a Genesis packet was sent out, which is a who am I query. You know, who are you? What is your address? So I can store on my side. Okay. So that's what this was actually over here that I skipped earlier, is this packet. Okay. So during the channel open ACK phase, this guy sent that Genesis packet out, and we just basically ripped it out and persisted it to this packet to relay data frame. It's over here. So let's go ahead. So now that we have this packet, right, and we already have Genesis packet dispatched. It's literally waiting on the Injective side channel. And what we do is we'll relay it now. Now we're gonna do the relaying process. The IBC setup process is done. Let's do our first relay over here, okay? So yeah, so whenever you relay, you also have to do a similar process to the open process where you basically update the client. So when you relay, right, we're basically calling a transaction Osmosis, right? Using the packet data from Injective. This requires updating the Injective like client, right? Here it is, update client. And we also need to get the proof, right? The packet of the proof. We need proof that, you know, hey Injective, I see this packet. Did you actually like post this packet, right? So we need to get the proof that go alongside with the packet data. So all that stuff is packaged together for this message, the message received packet. This is called on Osmosis, right? It contains the packets, you know, that Genesis packet information. I'll go and run it real quick. It has the proof of that packet. You ask Injective, did you publish that packet, the IBC packet? And this whole message also requires an updated Injective client to basically corroborate and tie it all together. Okay, cool. So it looks like we were able to relay it. So relay meaning that we call the transaction on osmosis, right, with the packet data here and all the other, I guess, consensus data. And now what we do is we will check the acknowledgement, right? So what that original package data was, or packet, sorry, was the controller contract simply asking, what is your address, right? So when we relay that message, that who am I message, you see that there, this contract has to respond to that command, that who am I command, and basically broadcast or respond rather with his address. Okay, and that's what this is right here in base64, basically. So this is the acknowledgement that's being sent back. Do they have a? They don't have a plain text version, unfortunately. We'll see it later. Okay, so this is the acknowledgement that was emitted, if you will, by the osmosis side ICA contract, and it is actually being queued up now on the osmosis side IBC module, right? When this guy publishes an acknowledgement, it itself is also something that needs to be relayed back to Injective, right? And that gets queued up here for relayer to basically pass back to Injective. Okay, so let's go ahead and relay it back. And again, when every time you relay, you have to go through the same process of updating the client. So relaying the acknowledgement message is basically calling on Injective with the message acknowledgement data, basically his contract address, and requires updating the Osmosis client, and as well as fetching the proof to go along with it, right? So we have to get the acknowledgement proof, which is what this is doing here, basically. So we got acknowledgement proof. Yep, looks good. And we will go ahead and package that acknowledgement proof with the acknowledgement, right? The packet that includes the address of this guy. And we will call that on the Injective chain, right? The Injective IBC module will route that properly such that our controller contract will basically hook into it and persist the address of this guy. So let's go and run that. Cool. Looks like it ran okay. So let's confirm, okay? I'm gonna run here. And yes, if you look at the controller address, that's this guy right here. He has, and you query for the list accounts query message, we do see the remote address, which is this. So that's what this guy's address is, okay? Let's persist some context. So we know, all the connection IDs, the channel IDs, last relay heights, stuff like that. Okay. And yeah, what we have, this is all done. We have set up our IBC channel, right, from scratch, and we have deployed an ICA contract, and we have relayed the Genesis packet between them, the Genesis IBC packet. So let's try something else. Let's actually do this. Let's actually issue a swap command from Injective to our smart contract wallet, right, our smart wallet on Osmosis without I guess leaving Injective, right? So here we will compose that message, right? So basically I took the protobufs, the Python protobufs for Osmosis. This is their balancer pool, I think. And we are composing what's called a Stargate message. A Stargate message is basically like any message, I guess, a bank message or a WAS message, just in one generalized format. So it's just a lazier way, if you will, of dispatching messages to a smart contract. And so what we're gonna do is we're gonna compose this guy here, this swap token 100x2y message, to issue that through our channel to our subordinate contract on Osmosis. Okay, that's what this all is. That's what this all is. Let's go ahead and compose that. Okay. And I'm gonna just take a quick look. And because we're asking for a swap, right? Because we're asking for a swap, we need to make sure we fund our smart wallet, right? Otherwise, he won't have the funds to, swap 100 Osmo to, whatever this thing is. This is testnet, so I wasn't able to easily find like what the injective counterpart is, but I just found this pool. But it's gonna be whatever this asset is. So what we need to do first, we need to make sure we fund it, since these are all freshly spun up with no, with no balances. So that's what this is doing right here. We're gonna send it 1,000 Osmo to kind of, have some pocket money to start off with. Okay. And what we'll do now is we'll do the relay. Okay. So I have a separate notebook to just do general, business as usual, sort of relay. All right. So again, let's just make sure we have a fresh card to start with. And again, import our stuff. Do we import that? Okay, cool. Right, so the first step, this first huge block is basically, all it's doing is just basically fetching all the queued packets, right? So over in the previous, down here, when we composed and created this message to basically do the swap, right? This has already dispatched an IBC packet, right? This guy has already dispatched this command, and it is effectively waiting in the IBC module of Injective. So what this does is basically fetch those queued up packets, right? And with those queued up packets, or we're going to forward those over, right, to be called on the osmosis chain. Okay. So here we are fetching it, and yep, we see one. It's just kind of rendering weird, but this is that one packet we sent, right? Yeah. Okay. And we could skip this for now, but this is basically the osmosis side version of any packets from osmosis to here. We don't have a controller on the osmosis side, so there are no packets that were originating from here. So we could skip this side. But this notebook is intended to take care of both sides. This is just a heads up. Right. So now that we have our packets, right, we have a packet here. We're going to go ahead and relay it. So remember, it's going to be that long process of, all right, we're going to update the injective client on osmosis, and we will fetch the packet proof right here. We fetch the packet proof to package alongside, right, the packet itself. And that will be verified with the updated light client, injective light client on osmosis. It's a mouthful, but that is relaying in a nutshell. Okay, and it looks like we have completed. Great. And I'm gonna skip the osmosis, or the injective side acknowledgement, because there's no packets to do there. And let's send the acknowledgement back. So this guy has already executed the swap. So let's check real quick. So we started off, we gave our contract, 1,000 Osmo of pocket money, right? Let's check how much he has now, just as a gut check. Okay, cool. And now he no longer has 1,000 U Osmo. He now has 900 U Osmo, or micro Osmo, and 8 of whatever this IBC asset is. So the swap has happened. Okay, so we have executed our cross-chain, interchain swap, utilizing IBC. Cool. So let's just finish off the whole process. Let's just finish off this transaction by sending the acknowledgement back, right? In this case, the acknowledgement doesn't have any useful information, just because there's nothing for the controller to do, really. But it's good to kind of finish off the loop, because the acknowledgement packet is generated here, or acknowledgement is generated here, and it's kind of waiting to be how should I put it, honorably discharged, if you will, by being relayed back to its originating caller. And that's it. We have done the whole loop. That's it. We have accomplished our goal of dispatching, or sorry, deploying, right, 2 smart contracts that talk to each other, right? And because they can talk to each other and issue commands to each other, they can leverage the relative, I guess, advantages and features of their counterparts' environment, right? From Injective, I can take advantage of all the stuff Osmosis has, through my Injective smart wallet, right? And vice versa. You may have an Osmosis smart contract, smart wallet, if you will. And you may be in a situation where you want to use some Injective native features. This helps. This is one way to tackle that problem. This multi-chain account abstraction, if you will, problem space. Anyhow, that's all I have for this video. Yeah. Let me see. Yeah, I think it's not worth going over that. So, oh yeah, one thing I want to just emphasize, all of the notebooks, the scripts, and all the resources are on our GitHub. GitHub under Bear Market Labs, the IBC relayer. We have a Docker container if you want to quickly spin up the notebooks that you saw today in this video to try yourself. Yeah, thanks. I think that's about it. All right, thanks.